Hi, welcome to my class. So, my name is Deepak Prakash and I am going to discuss one of the important topic from operating system subject, that is process concept. So, we'll see process management concept. So, let's start. Process management. Process management. First of all, we'll see what is process. Definition of a process. Process. Definition is program under execution is known as process. Program under execution is known as process. When we can say program is under execution, it should reside in main memory, then only we can say program is under execution. Okay, fine. Next, process will have various attributes. Process will have various attributes. Attributes means information about any particular process. Process will have various attributes. Process will have various attributes. There are various attributes, but we are going to discuss some of them. Some of them are a process ID. We'll see one by one. Process ID is unique identification number assigned by operating system at the time of process creation. Means it is an unique identification number assigned by the OS operating system at the time of process creation. Fine. It is an process ID is an unique identification number assigned by the OS at the time of process creation. Fine. Next attribute is process state. See, it contains means process state contains current state information of a process where it is residing. Fine. There are various states like new state, ready state, run state, terminate state, wait or block state, a suspend wait state, suspend wet state, suspend ready state. We'll see one by one in detail after this discussion. See, these are the various states. After this, we'll see next attribute, that is priority of a process. Priority of a process. Priority of a process. See, priority is means it is a parameter assigned by the operating system at the time of process creation. See, parameter means, suppose in your college there are various people, means students will be there, faculty, assistant professor will be there, associate professor, principal. So all have a different parameter, different designation. In same way, each process have different parameter, different priority assigned by the OS. Okay, fine. Next attribute is program counter. We'll see some of them. Program counter. In short, we'll see PC. See, it contains the address of next instruction to be executed. See, this is the work of program counter. See, there are various attributes also, list of open file, list of open devices, information security, but we saw some of them. In the next discussion, we'll see context of a process. Context of a process. Context of a process means, simply we can write list of all attributes. Attributes means process ID, priority, program counter, process state. These are the attributes. So list of all attributes is known as context of a process. This is the first point for this particular discussion. List of all attributes is known as context of a process. In next point, we'll write context of a process, in short, context of a process, COP. Context of a process will be showed in process control block. In short, PCB, process control block. What is process control block? See, process control block is a block where operating system can get information of a particular process. Here there are various information like what is the PID, process ID of a process state of a process, uh, like priority, what is the priority of that process, information security, program counter, list of open file. Uh, these are the information. With the help of this information, operating system can get the information of a particular process. So next point is every process every process will have its own PCB, its own process control block. Every process will have its own process control block. Last point is process control block. Process control block means this part. Process control block will be showed in main memory. In main memory, because if program under execution, then process will be in main memory. That's why if a process is in main memory, then PCB will also be in main memory. So after this discussion, we'll see process state diagram in detail. Process state diagram. So fine. Next discussion is on process state diagram. Process state diagram. See, this topic is very important topic. This particular diagram is very important diagram, because from this particular diagram, if you see earlier question paper in GATE exam, there are various questions only from this diagram. So we'll see one by one. First of all, there is a state, new state. New state. New state means process is under creation or being created, means new state. Next state is ready state. Ready state. Ready state means if a process is created, then it will be moved to the ready state. New state to ready state. See, in OS, in operating system, there are three types of scheduler: long term scheduler, short term scheduler, and mid term scheduler. We'll see one by one work of these all three. So LTS, long term scheduler, is responsible to bring a new process to the ready state, from new state to ready state. After ready state, there will be run state. Run state means CPU. We can say CPU. In ready state, there will be multiple processes, P1, P2, P3, etc. So one of the processes from ready state will be dispatched and moved on to the run state. Here, dispatching. And selection of a process is based on priority, and selection will be done by short term scheduler, STS. Means one of the processes from ready state will be selected and selected by STS, short term scheduler, and moved on to the run state and CPU or CPU state. After CPU state, there will be terminate state. After CPU, it will be terminate and it will be out from system. If in between the execution, if any process is running in run state and it requires input output operation, then it will be moved on to the wait or block state. Wait or block state for input output operation. If any process requires input output operation, then it will be moved on to the from run state to wait or block state, and it will perform their input output operation. After performing input output operation, it will move on to the ready state, means IO is complete. IO is complete. See, in ready state, there will be multiple processes. There will be multiple processes. But in run state, there will be only one process at any point of time. In run state, there will be only one process at any point of time. Fine. In wait or block state, there will be multiple processes at any point of time. It means multiple processes can perform their input output operation simultaneously. Okay, fine. See, these three states are means you know there are two types of memory, main memory and secondary memory. Main memory and secondary memory. These three states means ready state, run state and wait or block states are in main memory. Okay, fine. These are the in main memory. Next, if any process is performing their operation, input output operation in wait or block state, and in between there is a lack of resources, then that process will be suspended and moved on to the suspend wait or block state. Here suspending is done. Suspending. See, if any process is performing input output operation and in between of operation if there is a lack of resources, then that will be moved on to the suspend wait or block state. And if resources will be available, then it will be come to the wait or block state again to continue their input output operation, and after completing input output operation it will be moved to the ready state. Fine, means here resuming is done. Resuming, and if you will see carefully, then this is in main memory. This particular state is main memory, and suspend wait or block is in secondary memory. Suspend wait or block state is in secondary memory. So if any data, if any information, if any process is going to from main memory to a secondary memory and again secondary memory to main memory, then that process is called swapping. Anything is going to the main memory to secondary memory and from secondary memory to main memory, that process is called swapping. That is swapping. And swapping will be done by mid-term scheduler, MTS, mid-term scheduler. This is important point. So we saw suspend, wait or block state. After this state, we'll see there is a state suspend, ready state. Suspend ready. Name itself, it is clear that the process is suspended but in ready mode. So when process will go in suspend ready? If any process performing input output operation and lacking of resources, then it will come to the suspend, wait or block state. And if its input output operation has been finished, has been completed, then it will don't go from suspend, wait or block state to wait or block state. It will go from directly suspend ready state. Means that particular process has completed its input output operation. That's why it will go from suspend ready state. Okay, fine. Why it is going? Means IO operation completed, but lacking of resources. That's why process is going to suspend, wait, block state to a suspend ready state. Fine. After this, from ready state, it will also go to the suspend ready state. Why? Because if a resource is not able to manage a process, then it will go from ready state to suspend a ready state. And when resources will be available, then it will again resume and come to the ready state. Means here suspending, and here resuming, and here again main memory to secondary memory and secondary memory to main memory. Means swapping is also done here. So MTS is doing, mid-term scheduler is doing swapping. Swapping is done by mid-term scheduler. Okay, fine. So these are the basic concept of process state diagram. So in main memory, ready state, run state and wait or block state will be there. But in secondary memory, suspend ready, suspend wait block and suspend ready and new state. These three states are in secondary memory, and these three are in main memory. This is the very important concept. So we saw the process state diagram. One more thing is there. If a process is moving from one state to another process, then there is a concept of context switching. What is context switching? Context switching is nothing but saving the context of one process and loading the context of other process is known as context switching. Means if a process is switching from one state to another state, then its context are saving, and where it is going means ready to run, then the context of that process is loading also. That both the processes is called context switching, means saving and loading the context is called context switching. See, you can see here, let's say this is the run state. If P1 is in run state in earlier, if P1 is moving from ready to run, P1 is here, but after some time, if P2 is coming due to higher priority, then P1 has to be preempt. There is a concept of preempt. Preempt means just take temporary suspending, means in between of execution, P1 is moved to the ready state, but after some time P1 will get again CPU to execute its further execution. So P1 is preempt. Why preempt? Preemption is done because of priority or time quantum or time slice. We'll see the concept of time quantum in next discussion. Time slice. These are the reason, that's why P1 is moved to the run state to ready state. If P1 is preempt, then other process will come, P2. Means after P1, P2 came. So the context of P1 is saving, because P1 has not completed its execution, then context will save, and P2 is coming to the run state, then the context of P2 will be load. That's why here context switching is done. So saving and loading will be done. That is called context switching. Okay, fine. In next discussion, we'll see multiple CPU scheduling algorithms like first come first serve, round robin, short term SJF, short job first, long job first, SRTF, LRTF, means there are multiple algorithms. We'll see one by one. So thank you so much.